think one of you might have picked it up.
Oh, no, it's not. Nope, I don't have it. It was here. You don't have it?
Oh, nope, sorry, my bad.
Oh, okay, sorry. Oops.
Hello, everyone. Thank you all for coming to the second to last talk of the last day of ETC. So you guys are the real ones for sticking around. And as a reward, you guys will get to learn about the alpha of the future of blockchain and where everything is going. And the key word is Appchains. So you may have been hearing this word around a lot recently. You know, DYDX, I guess, helped push along some of that, get that up more publicly known. But I want to talk to you guys a little about the vision of Appchains, why apps are moving towards this, and just how things are going to play out going forward. So there's another word for what I call the vision of Appchains. It's this thing called Cosmos. One thing that, sometimes the terminology of Cosmos is a little bit confusing. What people might not often understand is it's not a blockchain, it's not a token. All Cosmos is, the word is just an idea, which is a vision of Appchains. And the tagline is the internet of blockchains, but yeah, it's just this vision and an idea. And so I'll start with kind of explaining what this idea is. So before we talk about the idea of Appchains and blockchains or anything like that, let's go back and just talk a little bit about development of human society. So what we see is at a very, very simplistic view, we can see that human societies develop in these three stages. So stage one was these villages and kingdoms, where they are relatively specialized but relatively isolated systems. There's not much trade between them. But then what you realize is people realize that you get all these benefits from larger scale aggregation and stuff. And so we started building these things called empires, where we said that, hey, look, through this mass scale political integration, we can build this great economic integration, put everything under a standard set of laws, standard set of measures, and if someone doesn't want to trade on you, you just march your army on them and make them trade with you, right? And then, in the last 100 years, what we've sort of moved towards, 100, 150 years, we've moved to this world of nation and city states, right? Where sort of the greatest innovation of the last 100 years or so is this idea of mass scale economic integration without mass scale political integration. And, we have this world where we have all these nation states deeply economically integrated, but without having a single global government. And how did we get there? How did we move to a world where we sort of stopped building empires? Well, it came through a series of social technologies over the last few centuries. One is free trade zones, right? This idea that you can, build bilateral, multilateral trade agreements that free trade has become the norm in today's world. Another one is institutions. You have institutions like the UN. It's not a government, but it's a forum for governments to come meet and discuss. So you have the World Bank, the IMF. These sort of institutions help create this globalized economic interdependence. You have the internet, obviously, right? With the internet, you can do economic interactions with anyone, anywhere across the world, and it gets even better with blockchains. And a big one, actually, people might not know too much about is this idea of containerization. And that doesn't mean Docker containers. That means if you ever go to a shipping port, you'll see that they always have these exact same shipping containers in every port in the world. And what this enabled was every port in the world can ship cargo to every other port in the world, because every port, every cargo ship is designed to handle this one standardized container format. And so this standardization of containers is very important. So that'll come in handy in a little bit. And so we can kind of see a similar development in blockchain development, where you have this generation one of blockchains. You have your Bitcoin, which is for payments. You have Namecoin, which is for DNS. You have Saya, which is for storage. But you can't use your Bitcoin to buy a DNS name on Namecoin and have it point to a file that's stored on Sia, right? There was no composability between these systems. And so to solve this, we created the Ethereum empire, where we say, hey, let's put everything under one common standard system, and we get this like great amount of like massive composability here. But it also comes with a lot of sort of drawbacks, which I'll get into in a little bit. But you know, empires charge fees to their subjects. Well, when you use Ethereum, you have to pay your gas fees in ETH. You lose a lot of the sovereignty that you get in Generation 1. So the vision of Appchains is sort of an amalgamation of the two past ideas, where can we still have the sort of sovereignty that we had in the V1 of blockchains, but still get the composability and economic interdependencies of the empire model of blockchains. And so this slide was actually, you know, from a talk that I gave like, I don't know, 3-4 years ago, back when this was still a very theoretical concept. Well, today that network actually exists, and it looks a little bit like this. So we have about over 50 chains in this sort of economically, you know, highly composable system using a standardized protocol called IBC, very similar to like the container stuff, where like, you know, a standard system that like allows any two chains to talk to each other in a very trustless way using on-chain like client proofs. Eventually you can upgrade to using fraud and validity proofs as well if you'd like. And so one interesting thing about this is most of these chains are actually app chains, application-specific chains. And why do people want to build these application chains, right? So, you know, we see a lot of them coming out very recently. You know, DYDX is migrating to its own app chain. You know, a lot of focus around like, you know, you can build these really cool products with them, better products than you might be able to otherwise. You see projects that, you know, spun off of chains that exploded, like Terra, and then you have apps sort of building onto their own blockchain, such as Mars. You have, you know, Bored Ape Yacht Club, you know, planning on moving on to its own chain eventually. So why are they doing this? What are the benefits? Why are we seeing this sudden rise of app chains? So, Osmosis, of course, is an app chain. We are a DEX app chain. And yeah, so why are we seeing this rise of app chains? And I'll kind of show some of the stuff why we decided to go the app chain route, and what are the sort of things that we're able to do that other DEXs might not be able to do. So one, I guess the obvious one is just, you know, scalability, right? So there's two types of scalability. There's what we call vertical scalability, which is, you know, you increase the amount of things that one system can do, whether it's a blockchain or a server or something. Horizontal scalability is you know, spread out the over many machines or many blockchains. But the problem is the most logical way to shard things horizontally is by application, because that's what has like high levels of data locality. And you know, you can have all these like rise of L2s and, you know, but if they're all using generalized execution systems in which every application is there, what you end up seeing is that all these L2s are sort of, you know, rebuilding internal ecosystems, and you're not really actually getting scalability benefits from that. You know, you look at Polygon, you have situations where, like, you know, a game suddenly shows up, becomes super popular, eats up all the throughput of the blockchain, and then, you know, it causes issues for everything else going on that blockchain. And you see this actually happening on basically every generalized L2, where if you look on Arbitrum, the treasure ecosystem ends up taking over a lot of the block space. If you look on Gnosis chain, you know, Dark Forest ends up eating up most of the block space. So if you have these generalized chains, you still end up competing for throughput in the same way that you would on base layer Ethereum, and it doesn't really solve the scalability problem. And so the solution to the scalability problem is, you know, you have the scalability trilemma that Vitalik pointed out. And he uses this like notion of decentralization, where it's the number of nodes that, you know, if you want to validate everything, you know, you have to be running a node for everything. But the problem is with this like framing is it doesn't take into account the fact that like most people are not users of every single application. When I run an Ethereum node, you know, I use Uniswap on a daily basis, you know, maybe I use Compound, but let's say I don't use Aave on a daily basis, or I don't use, you know, some random game that's running on or some, you know, NFT project, right? Like, why am I validating every single application when I'm not even a user of these? What this allows you, what the Appchain model allows you to do is you only have to run the nodes and validate the things for which you are a user of. And that means that some things will get more decentralization and security than others, and that's okay, right? It's probably okay for the MakerDAO app chain to have more decentralization and more security than, I don't know, the Nouns DAO, right? These are two very different applications that have different requirements. Another benefit you get with Appchains is you get this like high level of vertical integration. So, this is what Apple has done is they've built this like system where they control like high levels of the stack from the, they build a lot of the core apps, they build the software, they build the hardware, now they even start to build the components. And this gives them this like very tight control and like ability to create very cool things. So you kind of see other DEXs, often when they're building on top of an existing chain, they'll control their smart contracts and they'll control their front end, but that's about it. And that kind of limits them in the kinds of things that they can do. With Osmosis, we control the application, the smart contracts, but we also control the front end, but we also control the blockchain itself. And we also actually happen to maintain the Kepler wallet, which is one of the primary wallets for the Cosmos ecosystem. And so what that means is we have this full stack control from wallet all the way down to chain, and that lets us do some like very cool things, which we'll get into in a little bit. Another sort of benefit is sovereignty. So, this is a headline from a couple of years ago in a previous Ethereum hard fork where there was an upgrade to Ethereum and it broke a number of contracts that Aggarwal was using. And if you guys were here for Vitalik's talk earlier today, it seems that there's a plan to create more breaking changes in Ethereum. And the way Vitalik put it was like, it's okay if some things break, but from the perspective of the people who are building those few things that are breaking, that is not okay, right? Like, you can, yes, maybe if you haven't deployed yet, you can, read into these changes and plan for it. But if you're trying to build on-chain immutable systems, right, it's hard to build these things in a way that, like, you don't want the base system from breaking from under you. So if you have your own sovereign chain, that, things won't just get, the protocol you're building on won't just get rugged from underneath you. So what are some of the cool things? I talked about like, you get a lot of cool functionality you can do only with Appchains, but what are these kinds of things? So one is custom fees. So a couple of years ago, I was showing one of my friends how to use DAI for payments, and I was like, hey, this is so cool, we can pay each other with this. And I made him install a wallet, and I open it, make an account, and then I sent him some DAI, and I'm like, cool, now try sending it back. And it's like, oh, wait, he couldn't because he didn't have ETH for transaction fees. And it's like, man, this is like not okay UX. Like this stuff is never gonna, be usable if you have to pay like L1 assets for fees. So what's cool with a app chain is you could just use your own token for fees. So in Osmosis, you don't need some other token to pay fees. You can pay fees in Osmo. But one step above that is, what we've done with Osmosis is we allow you to pay transaction fees in any token you want, right? As long as it's, trading on the DEX, and so, it can, we have a general spot price for it. And that's something we can only do with an app chain because, we had to go change the core logic of our blockchain and how transaction fees work in order to enable that. But it also helps that we own the wallet because, we have to make sure the wallet supports this. And, by having this like full stack control, this is one of the things we can only do. And then you can, even take into account the application layer stuff. So one of the things that we're working on, as a DEX app chain, people pay swap fees when they make trades. We can allow the swap fees to count towards people's transaction fees. So that will sort of make the UX sort of even better, reduce a lot of the transaction fees for people. And then you can charge different transaction fees for different types of transactions. So one of the things that we do on Osmosis is if we detect that a transaction contains a cycle arb, we charge a higher fee for that just because, why not? They're making profit off of this. Why don't we should be able to charge a higher fee for this kind of stuff. Another thing you can do is custom precompiles, right? So, there's all this work on adding new functionality to Ethereum, whether you're, adding, new cryptography and stuff, but you have to like wait for that to come. There's been I feel like the amount of, brilliant human hours that have been wasted on like, designing systems to fit with the constraints that the EVM gives you today is just like really sad. If you have the ability to add custom precompiles to your chain, you can do things like custom cryptography. In Osmosis we do a lot of things with like, we're working on things with like custom signature schemes. You can do a lot of complex AMM math. You can do on-chain light client verification that is subsidized. You can do more efficient encoding compression that's subsidized as well. Another thing you could do is you can play with cool custom execution models. So you can do things like parallelizing computation. So on Osmosis, once again, it's a DEX. We have multiple pools that are, and things that are transactions that are trading against multiple pools, we can parallelize them because they're not touching the same state. And you can use like application layer semantics to inform parallelization at the chain layer, which is quite cool. You can experiment with new VMs. So we use a VM called Cosmos in Osmosis that allows you to, it's really cool. You can check the fun line of cool things of Cosmos. It's really like the best interchain native contracting system. You can have new types of asset models, right? So one of the things we're working on is making sure that all assets and tokens in Osmosis sit in a shielded pool, and then when you do a trade, it comes out, it swaps on the DEX, and it comes right back into the shielded pool. And so basically, all assets are sitting in a private system by default. You can do self-executing code. So batched AMMs, for example, instead of you have a bunch of trades on a block at once, instead of executing them in order, have some like unfairness with like sandwiches and all this stuff, you can take all the transactions, all the trades in one block and accumulate them at the end of a block and have them automatically be run batch with each other. So kind of having almost something like cow swap, but natively in the protocol, no risk of censorship or anything like that. You could have protocol-owned liquidations. You can have code that's like just runs at the beginning of every single block and just checks a few things and says, oh, okay, these things can be liquidated. It can liquidate them for protocol health and safety rather than relying on these like off-chain keepers to do that. You can build in-protocol arbors. So this is one of the things that we're building as well, which is, at the beginning of every block, we can have a on-chain arbor that automatically runs. It's not going to be perfect because solving the ARB is like an NP hard problem. But if we can use heuristical systems to even capture 50% of that ARB profit and distribute that to stakers, that's like protocol revenue that could be captured rather than giving it out to others. You can make your validators do more for you. So you can have your validator provide price oracles. This is something that the T-word blockchain did, where they used to Terra used to have their validators provide price oracles. So you have oracle pricing that's like atomic with the block production itself, which is quite cool. You can require your validators to have certain node requirements, such as an SGX or a GPU or storage systems. Like, for example, there's a NFT-focused Cosmos chain called Stargaze. They're going to be requiring their validators to run like IPFS pinning services, and makes it easy for these NFT projects. You can do off-chain computation. So one of the things that DYDX is going to be doing is they're actually going to be running their order books in the mempool. So you basically require validators to do this matching engine off-chain and then sending settled transactions on-chain. So this is quite cool, where we can see that this is actually very helpful. You can have your validators be required to run bridges, so that way the economic security of your bridge is equivalent to the security of the chain because it's being run by the same validator set. You can do custom transaction ordering. You can, MEV mitigations. You can have your protocol sort of look and, disallow sandwich attacks. You can, have this batching system in chain. You can prioritize certain types of transactions. So, for example, Oracle updates. You can look at all the transactions. You can say, hey, this is an Oracle update. We're going to make sure this goes at the front of a block or something like that. And you can also do built-in flashbots, right? So instead of relying on an off-chain system like Flashbots to have transaction prioritization systems, you can do this on-chain where, you can say, hey, we're going to let any transaction bid on the first transaction slot in a block. And the results of that auction can be given to all the stakers of your chain. So once again, this is this form of protocol of revenue. So this is a tweet from Anatoly a couple of weeks ago. He's like, the biggest thing that L1, the real value of L1 tokens is just the MEV that they can capture. So as an app developer, why are you leaking that value to some L1 token instead of capturing that as protocol of revenue for your token holders, right? So by having an app chain, you can allow that MEV to be internalized into your protocol. Custom staking systems, you can have your own staking token, use your token as a staking token. You can do custom slashing conditions, right? So you can say that like, hey, along with basic safety stuff, I want my validators to provide data availability, so we're going to give them data challenges, and they're going to have to reply to them, and if they don't reply to them, they get slashed. And basically, this kind of goes in line with making your validators do more, but with these custom slashing conditions, that's how you do that. You can do things like superfluid staking, which is something we do in Osmosis, which is allow you to use application-level assets in the proof-of-stake system. So our staking token is called Osmo. And a lot of our liquidity pools will have, let's say it's Osmo paired with ETH, right? You can take the LP share of that. And our protocol, because our chain understands the DEX, it can say, hey, look, this LP share has this much Osmo underlying it, so we can allow you to use it in the proof-of-stake system. You can stake the LP shares themselves and help secure the chain. This is sort of like an alternative to staking derivatives. Staking derivatives can, carry with them all this like security risk. They kind of undermine this, Evan just gave a good talk on this right before me, how they kind of undermine a lot of the security properties of proof of stake. Well, this is a way of like sort of getting a lot of the benefits. You can use your assets in both DeFi and proof of stake at the same time, but in a more secure way. But this only works when your chain knows about the application. Ethereum can't use Uniswap LP shares in its proof of stake system because it doesn't understand Uniswap LP shares, or even something as simple as wrapped ETH. It doesn't understand the concept of wrapped ETH, right? It only understands its native system. And what about rollups, right? Like, okay, application, a big thing I've been hearing recently is about these like app chains versus rollups. So what is the benefits and pros and cons of these? So, with rollups, one, if you look at the state of rollups today, they all have sort of these generalized execution systems, and it's pushed everyone towards this EVM compatibility. Creating fraud and validity proofs is really hard. So instead of like, we don't really have systems for creating application-specific rollups today. And I think eventually it will get there. So, we see things like Cairo and stuff that are making it easier and easier. But it's still a ways out. The ability to build custom things, custom application-specific blockchains is like, you can just move way faster when you're using something like the Cosmos SDK. You can write in Go, and iterate on the application layer composability, on the UX. And then once these validity proof systems come around, you can easily change your chain security model to using those in the future. I think really the long-term end goal of all of this is that shared security is not going to be this like hub and spoke system where like, there's one base chain and then there's rollups on top of that and maybe rollups on top of those. It's going to be a bunch of application-specific blockchains that are providing validity proofs to each other and are sharing slashing conditions. So, at some point we have to admit that like, look, most of these blockchains have like greater than 50% overlap in validator sets anyways. So, what will end up happening is validators will opt into like joint slashing conditions where they'll say, hey, if I do something malicious on Osmosis and I get slashed there, Osmosis will send that as a validity proof to all the other app chains. It'll send it to Mars and DYDX and everywhere, probably even Ethereum 2.0, and my validator will get slashed on all of these chains as well. So this is sort of how we will, unbundle the value that's being captured in L1 tokens and move it back into the application tokens, because, why are we leaking that value? And so, yeah, that's end of it is I want you to start building app chains. Thank you. I have time for one question. Yes. I don't have time for one question. What if it's fast? It's 30 seconds. Okay. Thank you.